For this problem, we need to determine the required force P that must be applied at the blade of the pruning shears so that the blade exerts a normal force of 20 pounds on the twig at E. So it's hard to tell in this problem what the pieces really are. So remember, no power tools, I'm just taking out the pins. And so it turns out when you do that, you have this piece as one. Okay, so that will be one piece. And then the other piece is the A leg here. Okay, so for that one, I'm going to take the pin out at A, and then I have BC as a 2-force member. And then we have the other piece behind here. That could be our third piece. So to start, remember, we are always going to do a free body diagram. And when we're dealing with frames and machines, usually that's one of the whole thing, and then the parts. For this one, the whole thing won't really make any sense because we'll just have P, and then maybe I take out the twig, but then I'll have E acting on the yellow piece and on the blue piece, which it just gets us nowhere. So instead for this one, I'm just going to be drawing the free body diagram of each of these pieces. So let's see, we'll draw the blue one first. And, you just kind of need a general shape. It's not a big deal if it's not perfect. We just need a little bit similar just so we can get those dimensions right. So once I kind of have the outline, then I'm going to look at everything that I've removed and everything that acts on this body. So we'll see that P will act there. And then I removed the pin at D. So at D, I'm going to need a DY and a DX. And then I also removed the pin there at A. And they show in the picture that D and A are perfectly in line based on that line I just dotted. So I'm going to draw them that way on here. So I'll have AX and AY. And for AX, AY, DX, and DY, I'm just guessing a random direction. I've really put no thought into it. So if you choose a different direction, it doesn't matter. I'm just going to be consistent in my work. And then lastly, we have E here, which is going to be normal to that surface. Let me kind of write E a little bit closer there. So that leaves all of my forces for that one. And then once I draw my body, I like to kind of check and make sure I have distance information I need. So this E here, we have that as 1 inch from A and from D. Our distance from D to A is the 0.5 inches. And then I just need this horizontal distance from A out to P, which will be the 0.75 plus the 4. So that will give me 5.5. Okay. So that's one body. And then the other body I'll draw is that red one. So that will be just something like this, where I'm going to have A here, and I'm going to draw my forces equal but opposite to how I drew them before. So I have AY down this time, AX to the right. And then I have B here, which acts to C here. All right, so we have BC, that's a 2-force member. I noticed in the picture that A and C are perfectly in line, so I just wanted to keep that information on there. And then this distance here is 0.5 inches, and from A to B vertically, that's going to be 0.75. and another 0.75 out to where C is. And then, of course, I have P, that acts here. And so from A out to P, that's, let's see, so from C to P, that's the 4 inches. But from A to P is still that 5.5, but I'll write 4 here. Okay. So I can see in this body that I have 4 unknowns, okay? And in the body above, I have 5 unknowns, because remember, E was given to us as 20 pounds. So that means that neither of these bodies have 3 unknown, right? So there's not an easy choice right away to say, oh, I start with this body, solve this, move on. And if I add up my total unknowns, then I have 6 total unknowns. So I know that with these 2 bodies, I should actually be able to solve for all of the unknowns that I have here. And in the end, I really only need P, okay? So my first thought is, okay, so for me, my first thought is a moment at D. And the reason I say that is because I see that AX and AY show up in both of these free body diagrams, but DX and DY only shows up in the one. So in my mind, I feel like if I take a moment at D, that's perfect, because I don't think solving for DX and DY is going to help me at all. But if I take a moment at D and I could get AX or AY to relate to P, since E is given, then those are the only unknowns there. Then I could use that in the next free body diagram to reduce my unknowns to only 3, so that I just have P, BC, and then either AX or AY, hoping that one of those is something times P from my previous step. So what I'm going to do there is start with that moment, because to me, that's the best option, because like I said, I don't think that I need DX and DY in this problem. So another way to think through exactly the same sort of thing is if I take a moment at B or C, so that I have AX or AY from that free body diagram related to P. And the only reason for me that's not as good of an option is because the blue body has more unknowns. And so I have to reduce 2 of the unknowns for the blue body, but I only have to reduce 1 for the red. So that's why I'm going to start with the blue, take that moment at D, set it equal to 0, and then I'm going to have E, which will be times 1 inch. Okay, please don't forget the 1 inch when you guys are showing your work, because a lot of you will just write E, and then it looks like you're trying to add pounds to pound inches, which doesn't work out. So even though it's the number 1, the unit really matters. And this is going to be a counterclockwise, so I'm going to add it. We can see that AY is going to go through D, since A and D are perfectly in line vertically. So I'm just going to have my AX there, and that's going to be times 0.5, and that will create a clockwise moment. And then my P will also create a clockwise moment, and this one will be times 5.5. So that should equal 0. So remember, E is 20. So I'll have 20 pounds here times 1 inch. So I have a 20-pound inch minus AX times the 0.5 inches minus P times 5.5 inches. So for me, I'm going to solve for AX as a function of P. Since P is the thing that we want in the end, I'm just going to try to solve what I can as a function of P and see where I go from there. So that means that if I add AX over, I'll have 0.5 inches times AX will equal 20 minus P. So then I'm going to divide both sides by 0.5. So that AX here, this will become 40 pounds since the inches will cancel. And then this will become, the 5.5 will become 11 P. Okay, so the units here are pound because this 11 has the inches will cancel as well, which makes sense because we need AX to be in units of a pound. Okay, so that's one equation that will help me. Now, so I'm going to note that this is with free body diagram 1. Well, I'm going to label this one 1 and this one 2. So then I'm going to go to free body diagram 2. And I have AX now as a function of P. So that leaves AY, BC, and P as my 3 unknowns, which means that I'm going to be able to solve for all 3 of my unknowns in this problem on that body. And remember, P is the one that we want. So whenever I know that I have 3 unknowns, then I can take a moment, then I can sum forces in the X and the Y, and any combo of those 3 equations will lead me to the answer. The first thing I'm going to decide to do is just take a moment at A. Now, it's not necessarily the best and quickest choice to get to the answer of P, but for me, I know I'm going to be able to get the answer that way. And I like to take moments where my pins are. It normally leads me to, a good answer. So I'm going to go ahead and take that moment at A with free body diagram 2. And that means AX and AY will be times 0. So I'm going to have BC. I'm going to have the Y component. What I'm going to do with BC is I'm going to say that it's acting at C. So I'm going to have my BCY and my BCX. They both have to act at C. And we can see the X component is in line with A. So I'm just going to worry about my BCY. And that will be times 1.5 because that's the distance from A out to C horizontally. And then this will be counterclockwise, so I'll add it. And then my next one is for P, which is also counterclockwise. And from A out to P is 5.5 inches. So this will equal 0. So now BC, Y, that means I actually need to get the angle for BC. So I'm going to come up to the original picture here. And I'm going to use this triangle from B to C. So I can get this angle here. Okay. I have 0.5 and then 0.75. So that gives me the tangent of theta of 0.5 divided by 0.75. So theta then would be the inverse tangent of 0.5 divided by 0.75, which gives me 33.69 degrees when I put that in my calculator. So that means then, because this is similar to the BC as a force, BCY, BCX, make sure that you don't label this BC, okay? Because that's a force, and you can't have a force and a hypotenuse where you have length on the legs, all right? So these are similar, which just means that BCY here will equal BC sine of that same angle. So I'll have BC sine of 33.69 times the 1.5 plus 5.5. P is 0. And what I'm going to do is solve for BC. So it'll be some function of P. So this is going to be minus 5.5 P divided by the 1.5 sine of 33.69. And when I put that in my calculator, I get negative 6.610 P will be BC. Okay. And, so obviously I didn't solve, but now I have AX and BC as a function of P. So whenever I take a moment, then my next thought is to go ahead and sum forces. I'm going to sum forces in the X, since I have AX and BC as a function of P. So this will give me AX plus BCX is equal to 0 since both components are toward the right. AX I'm going to replace with 40 minus 11P. BCX would be BC cosine of 33.69. But now I can substitute what I have for BC to be negative 6.610P, all right? Don't forget, whatever you solve here, the whole thing gets plugged in, including the negative. Every time you see BC, the whole thing will get plugged in, including the negative. Cosine of 33.69, this equals 0. So I'll end up with, let's see, 40. I'm going to add both of my p's over. So I'm going to add the 11p over, add this 6.610 cosine of 33.69p. So this will equal 40 because this term ends up negative, right? So then I'm just going to add my constants here so I can get p. This equals 40. So we're going to say 11 plus the 6.610 times the cosine of 33.69. That gives me a 16.4998 here, so 85 even, so I'll have another 9. So I'm going to divide both sides by that. So we'll have 40 divided by, and I end up with 2.42 pounds. That's my final answer. Okay. So this is, of course, not the only way that you can do it. You could have chosen to take a moment at B, a moment at C on that second one. You could have decided to sum forces in the Y, and then the X, or, so there's lots of options here. This is just how I chose to solve it. So same thing, I chose to take that moment at D. You could have taken the moment at A, related, solve for dx, then summed forces in the x to relate ax to dx, which would then relate that to p, and then go to the next one. So there aren't like wrong options, as long as you are applying your equilibrium equations correctly, it will lead you to the right answer. I just want you to remember that you have those three. You take a moment at whatever point you want, some forces in the x, some forces in the y, and when you use those and get some combination of them, at that point you have this little puzzle where you have to figure out how they connect for you to solve. So knowing that I have 2 bodies, 6 unknowns, 3 equations per body tells me that whatever I do, I'm going to be able to solve. I found a way to solve with 3 steps. I saw students in class find a way to solve in 2 steps. I saw some students in class solve with, all 6 steps, right? It doesn't really matter. They're all correct. But this is my thought process, that I always choose moments at pins when I'm dealing with frames and machines. I just find that to be usually a really smart choice because I get rid of 2 unknowns. When I have a machine or a frame and I have only certain things they're wanting me to solve, then I will often take a moment at the pin that doesn't move me to the next body at all. So that's why I chose D, because AX and AY are in my other body. So I wanted those to stay into my equations. But that's it. That's my thought process. So again, you might do things slightly differently, and that's okay. If you got P to be 2.42, then you did a great job. Whatever you did was probably correct. If you notice that you made an error, then, it might have been just in your moment, or you missed a negative or something like that, more so than because you did it a different path than me. All right. So keep that in mind. And hopefully this helps you guys learn how to do this problem.